Hello everyone and welcome back to Arctic Retro. This is just a short little video that is auto-banned from the regular schedule, but I thought I'd just make a small video about something that has irritated me, and that is chips with bent legs or pins that doesn't fit into sockets. So the problem with the ICs that haven't been in a socket before or you buy new is that they can get hard to fit into the socket, and also if you have bent pins like this, I usually have to use some pliers to try and bend them. I usually use these are bent needle nose pliers, and yeah, try and straighten them, or if it doesn't fit in the socket at all, I sometimes have to bend all the pins at once. So I use a little bit force like this, but yeah, it can be hard to get it to fit correctly, and when you then push it in, sometimes a pin or two just get bent underneath, and you risk breaking off one of the pins. That has happened to me before. No, of course there are tools for that. I have seen other YouTubers use this tool here, for example, bending or straightening all the pins on IC at once. And these are quite cheap, cost like 100 NOK or something like that, maybe $15 to $16, including shipping. But since I am quite cheap at times, I don't want to spend money that I don't have to spend. So I actually checked if I could 3D print one of those tools, and yeah, let's take a look. So here I am on thingiverse.com. This is a portal where you can find all sorts of 3D models that creators have uploaded, and yeah, everything is downloadable for free, but you are of course asked to give donations to the creators. So I search for IC pin bender, for example, and here we have some of those. This one, for example. So here I search for dip bender, and yeah, there's a couple of variants, but I thought this one looked to be perhaps the best. And it takes two sizes of chips, one on each side. So I'm gonna print that now, download. And then I just load it into the Prusa Slicer software. Slicer is a software that you have to use to produce the file that the printer actually needs, because it can't simply print a 3D model or a STL file. It needs to slice it, and that means that it makes the 3D model into these thin slices that forms the basis for the print and each layer that the printer is gonna print. So you can select to do a fast print that's not that accurate, or you can use very fine print, 0.10mm detailed or ultra detailed. But I'm just gonna select 0.2mm normal. And then there's a lot of settings and adjustments, but for simple models like this, I suppose it doesn't need much. If you have like advanced models that has overhangs, of course the printer cannot print into the air, so you need to then add some support materials. But it looks like this does not require that, so I'm gonna slice it now. And here we can see all the different layers, and if we use this tool here, we see each layer. And you can run up and down And you can actually see that the solid blocks are not completely filled. They are made up of these mesh structures that saves the material that you're printing. And we now see down here that it's going to use 8.62 meters of filament, and it will take around 2 hours to print. So now I export that G-code and save it and copy it to a memory card that I insert into the 3D printer, and I'm ready to print. Now I could of course have connected the printer directly to the PC, but this is in another room and would require a long cable, and having it in another room, I don't have to listen to the noise it makes if I'm working on something else. These are the remains of the last print. Right now the filament I have inserted is white, so I'm gonna use that one. Before I start the print job, I always clean the print area. This is a metal sheet. And when you start printing, the printer heats up the whole heat bed sheet, and yeah, to around 60 degrees Celsius. And it also starts heating up the extruder that melts the plastics, and then it starts printing the layout, and off it goes. Just gonna select print from SD. So now it starts heating, and it is 22 degrees, and it is going up to 215 degrees on the extruder and 60 degrees on the plate. The heating goes quite quickly. It takes a couple of minutes only. And it now displays here total printing time is 2 hours and 7 minutes. And there it goes. And first it will print just a little bit over in the corner to dispose of the first plastic that are in the extruder. But before that, it just do a little bit of measurement of the leveling of the heat bed. Now it prints that first portion of plastics just to get rid of what was in the extruder. And then it prints the outline of the model that I'm printing. And this first layer is always important to get the correct thickness so that it sticks to the plate. Otherwise it might get loose under the printing, and then everything will just get a mess. I always watch the first couple of minutes to see that everything starts out okay. So now it seems like it is correctly printing the first layer, so I'll leave it here now for 2 hours. Alright, the print finished, and everything went okay, and it is looking very nice. And it works. How durable it is remains to be seen. It might happen, of course, that the plastic will eventually crack, but then I can just print another one. It's not been used that often, I think. So let's check it out. I have a couple of old broken chips here, and I deliberately bent the legs on these. Let's try this one. Maybe I overbent them a little bit. That is perhaps a little bit too much. Yeah, that seems to work. Let's try this one. I have bent the legs a little bit outwards. The trick is to get an even pressure and even straightening on all the pins. And it actually seems to do a pretty good job at that. Let's zoom in. Yeah, does it now fit right into the socket? Yes, it does. Very nice. Here's a smaller one. Let's try that side. Yeah, it bends the whole row of pins evenly, but the individual pins are a little bent themselves, so. But it fits right into the socket. These are unused chips, I think, and with new chips they're always bent quite a lot out and doesn't fit right into a socket. The pins are too wide actually, and that is the case here. I'm not sure if you can see it, but so to get it into the socket you need to bend the whole row of pins on both sides, and that can be a little bit tricky. So let's try this one then. Yeah, that works perfectly. Very nice. So yeah, I'm really pleased about that. This simple device seems to be working as designed. Alright, that was it for this short video. A new tool in my toolbox. That's great to have. So, hope you enjoyed the video, and as usual, thanks to my sponsors and to my Patreons. See you all. Bye bye.